Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 6 minus n to the power of 3 is equal to 2, and we will solve this problem for real values of n. So here you remember one thing, we can just find the real roots of this equation, so that the very first thing we are going to do is, here first I can rewrite this term as, here we have n to the power of 6 and we write it as n to the power of 3 and its whole power 2, because here I can apply the nice exponential law. According to this law, if you have a to the power of m to the power of n, it is equals to a to the power of m times of n. It means that if you have exponent to the exponent, so these exponents are multiplied by each other. So here you get minus n cubed is equals to 2. And now we convert this nice equation into the quadratic form, so that we will take here y is equals to n to the power of 3. So when we put y is equal to n to the power of 3, so this expression will becomes y square minus y is equals to 2. And now we move this 2 in the left hand side, and you get y square minus y minus 2 is equal to 0. So this will convert in the quadratic form, and now we make the factors of this equation, so that here we need two numbers whose product is minus 2 and whose sum is minus 1. So these numbers are minus 2y and plus y. When you add minus 2y plus y, you get minus 1. When you multiply these two, you get minus 2 is equal to 0. Now we take common y from these two terms, and you get y minus 2 plus, here you take common plus 1, and you get y minus 2 is equal to 0. So now we take common y minus 2 from both of the terms, and you get y plus 1 is equal to 0. So here you have two cases. The first case is we take y minus 2 is equal to 0, and the other case is we take y plus 1 is equal to 0. So in the first case you get the value of y is 2, and in the second case you get the value of y is minus 1. So now we back substitute the value of y. So here we have the value of y is n cubed. So we back substitute here, and you get n cubed is equal to 2, and when we put here you get n cubed is equals to minus 1. So now we move this 2 in the left hand side, and you get n cubed minus 2 is equals to 0, equal to 0. Similarly here, when you move this minus 1 in the left hand side, you get n cubed plus 1 is equal to 0. So here you have two equations. I can name this as equation number 1 and this as equation number 2. So I can solve these two equations one by one. So first I will solve equation number 1. So equation number 1 implies n cubed minus 2 is equal to 0. So now I can rewrite this equation as n cubed minus, here you have 2, and I will write it as 2 to the power of 1 over 3 and whole cubed is equal to 0. So now here you focus on this term, and it will becomes the nice cubic formula. And you know that if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So now I can apply this formula, and here you have the value of a is n and the value of b is 2 to the power of 1 over 3. So we put these two values here, and you get the output in the form of n minus 2 to the power of 1 over 3 times of n square plus n times of 2 to the power of 1 over 3 plus, here you have b square, and the value of b is 2 to the power of 1 over 3 and its square is equal to 0. So now we simplify this term and you get n times you have here we have two cases. The first case is we take n minus 2 to the power of 1 over 3 is equal to 0, and the other case is we take this term is equal to 0. N square plus 2 to the power of 1 over 3 times of n plus 2 to the power of 2 over 3 is equal to 0. So in this term you get the first root of the given equation, first real root of the given equation, which is n is equal to 2 to the power of 1 over 3. So this is the first root of the given equation, and this equation will gives us the other two roots, but these two roots are complex roots or imaginary roots, so that we will rejected these roots because here we need only the real roots. So that this is the our first root, and now we solve the equation number 2. So equation number 2 implies that the equation number 2 is n cubed plus 1 is equal to 0. So now we solve this equation. So in this equation here we again make the cubic formula, and we write this equation as n cubed plus 1 cubed is equal to 0. And here we have the nice cubic formula, which is a cubed plus b cubed, so that it will becomes a cubed plus b cubed is equals to a plus b times of a square minus ab plus b square. So this is the nice cubic formula, and here we have the value of a is n and the value of b is 1. So we put these two values here, and you get the output in the form of n plus 1 times of n square minus n plus 1 square, it is 1 is equal to 0. So here we have again two cases. The first case is we take n plus 1 is equal to 0, and the other case is we take n square minus n plus 1 is equal to 0. So in this case you get the other real root of the given equation, which is n is equal to minus 1, and in this equation you will again find or get the complex roots. When you can solve this you get the complex roots, but here we need only real roots, so that we will rejected this case and we can just find its real roots. So finally we have two real roots of this equation. So these roots are n is equal to 2 to the power of 1 over 3 and minus 1. So these are two real roots of the given nice equation, and this is our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.